earliest forming galaxies in the universe radiated a lot of ultraviolet. So you might say, well, let's get an ultraviolet telescope. No, because 14 billion years later, the expansion of the universe has redshifted the ultraviolet into the infrared. Oh. So if you want to see the birth of galaxies, you got to know what they look like in the here and the now. And in the here and the now, it's in the infrared. So this is a telescope specifically tuned to see galaxies born at the edge of the universe. And infrared also allows you to see deep into gas clouds.
Now, when they're showing you an image like
this. So right here, this is the pillars of creation, which were so named at the time Hubble first attempted this. We were gaga over the Hubble image of this. And now, like the JWST, oh my gosh. For those who are more prone to religion, some have called this the hand of God. Because if you look at the pillars, you can kind of picture like a thumb and fingers, yeah. So, but regardless, this is nearby. This is the telescope peering deep into gas clouds that otherwise would enshroud what's going on. And you get to see stars being born, planets being born. And so what's remarkable about JWST is that to be tuned for the edge of the universe and the birth of galaxies is the same properties you would want to see the birth of stars. A star is born right in front of your nose that would otherwise be cloaked by gas. And infrared penetrates those clouds and enables you to see it as though the cloud isn't even there. And you already know this because if you're driving through fog, okay, you put on your fog lights. The fog lights are not blue. They're like reddish, amber, okay? That improves your ability to see through the fog. If we could see infrared, that's the kind of light you'd use, then you wouldn't even know the fog was there. That's why self-driving cars will be amazing. It won't matter if it's foggy. They'll be able to see everything. Just give them infrared sensors. The fog is irrelevant. They can drive 100 miles an hour in dense fog, and all the cars will see each other. And they want to change lanes. They tell other cars, I'm going to change lanes. They'll part for them, open up, and we won't get 40,000 deaths a year, as we currently do, from automobile accidents.
Now, how much bigger is this telescope?
So, so you want to think about collecting area, and I forgot the exact number. Something like 8 times around there, more powerful in the sense of it can see things 8 times dimmer. There you go. So that's wow. There's about 2.5 squared. It's about 8 times the area.
And the technology obviously is improved as well. So like the ability that...
Well, our detectors are better. And let me remind you that when the Hubble was designed, it was designed in like the 1980s. And it was scheduled to go up. And then we had the Challenger accident, and that delayed the shuttle program. So there's Hubble sitting there in mothballs with an old Microsoft chip, and by the time it launched, it was already not as fast as it could have been. And so the very first servicing mission swapped all that out and put in better methods and tools for measuring what it is we always needed it to do. So one sad part about this is that it's not serviceable. We have no access to that point in space 1 million miles from the moon. We haven't left low Earth orbit since 1972. We're not going out 1 million miles from Earth to fix a telescope. So that's unfortunate. Maybe a robotic fix, I don't know, to refill some of the fuel. It needs fuel to station keep.
Didn't it get hit by a micrometeor?
Yeah, well that's the brakes when you're in space.
Yeah.
Yeah, but it doesn't affect the overall performance.
That's amazing.
Yeah. Well, it's huge, and micrometeors will do small damage, but you don't want it in the middle of a meteor storm. That would be
right.
Totally bad.
And do they? I mean, they obviously know like where some of the asteroid belts are and where some of the nearby Earth objects are.
Yeah. So in this context, so first, most asteroids are in the asteroid belt. So that's between Mars and Jupiter.